Hi, thank you for joining in our Autodesk Eagle webinar series. Today's topic is about Eagle and Fusion 360. As you already know, Eagle and Fusion 360 offer a true electromechanical workflow. Today, Jorge, our Eagle support specialist, will be demonstrating possible one of the most common workflows. Today, we'll generate a board outline in Fusion 360, which will be imported into Eagle. From there, we will populate the board and push it back to Fusion 360 for a true mechanical 3D model. From here, we can create an enclosure, move components, or even edit the board outline. Now, please notice that throughout the entire process, no file conversions are required. Now, let's go live with Eagle.
Okay, what we're going to do is we're going to start with a sketch here in Fusion, and we're going to pull that into Eagle. You can start either way. You can start from Fusion, pull into Eagle, or start in Eagle and push to Fusion. So we're going to start here. So we're going to click on the sketch. We're going to create a sketch. We recommend that you use the XY plane to create your board. Okay, I'm going to use a little 2-point rectangle right here. I'm going to make it 50 by 30. Okay, so now what we're going to do is we're just going to add a couple of little features to this. I'm going to use, again, all of the sketching tools. And there's a million different ways to do this, so you can just use whatever feels good to you. So I'm going to add in a fillet, 5mm here. I'm going to add another fillet. Make this one 10. Okay, and we're going to put in another one here. 5mm. Okay. And then the other thing we want to add is just a circle, just to have some variety. Okay, 5mm there, and we have our finished sketch. Okay, now what we can do is we can turn this into a board simply by going Create and Create PCB. Now this is only active if you have the preview set up. So if you go over here, go to Preferences, you go to Preview, make sure PCB feature is checked. Okay? Currently this functionality is still kind of in a beta-ish state, so you have to go over here to Preview and make sure it's active. Otherwise it won't show up if on the default install of Fusion 360. So we can go Create PCB. Okay. We're going to go ahead and select the profile. Okay. We can specify its thickness. This is a default normal thickness for a PCB, 1.57. It's very important that you specify an origin. Okay, because the origin is basically the reference point that Fusion 360 and Eagle share. Depending on how you place your origin, when you import this board into Eagle, you may get it flipped sideways or reversed or something like that. So we generally recommend drawing the XY plane and put the reference point, the origin, on the bottom left corner as it shows here. Okay, there we go. There's our PCB.
Now, I wanted to mention here as well, interject really quick, Jorge, that in addition to creating the PCB this way, we've learned of some users that actually will import DXF files. And based on that DXF file, because it might be a really complicated board outline, you could import that DXF file. And that DXF file, you could actually create or convert it to a sketch, which then will allow you to create the PCB. Just to let you know. The nice thing of doing it, you see, Eagle can import DXF files as well, but being able to bring them into Fusion 360 just gives you that much more editing capabilities than Eagle can handle right now.
We're going to go ahead and save this so that way we can bring it into Eagle. So click here, Save. I'm going to call it Live PCB. Hit Save. Okay, perfect. Now what we're going to do is we're going to go to Eagle. Okay, and we're going to go File, New, Schematic. Immediately going to create the board from it. And first thing I want to do is save. That way we have a name and we have a design. Okay, call it Live. Can I export a 2D sketch of an enclosure from Fusion360 as well? Yes, you can. There are some drawing features in Fusion360, although we're not going to be going into that in this demo, but it is available. So we're here, schematic and board. We have saved them. What I want to do now is I want to have some circuitry that I can push. So I'm going to use a design block. I created a little 555 timer design block earlier. Okay, let's rotate that. This is fine. I'm going to put it over here near the corner. Maybe like there. Okay, there's no old name for the signals. Usually what will happen when you bring in a design block, Eagle will check to make sure that there's no conflicts with the layer names. Usually the power signals, as you can see here, denoted by supply pin, those will retain their names, but anything that's not a power signal will actually be renamed. In this case, there's nothing pre-existing, so they can preserve their names. Say OK. Everything is in. And now what we're going to do is we're going to go Fusion360. We have the option to link to an existing Fusion design, which is the one we're going to do, or create a new Fusion360 design. So the new Fusion360 design option is used whenever you're going to have Eagle start to dance. So you started the board in Eagle, now you're going to push it to Fusion so that your mechanical guy can check it out. In this case, we're starting from Fusion360. So I'll click Next. Okay, it's going to link to your Fusion360 account, webinar demos, and I want to link to live PCB. Pick that, say OK. And then first thing I'm going to do is pull from Fusion. That way we get that outline into Eagle. So click Pull, item was created, pull. Alright, perfect. We can see that it came in. I do have a little overlap, so before I push it back to Fusion,
as you can see, the live DRC kicked right in as well.
Yep.
Could you make that just a tad bigger, Jorge? That way we could see it.
Better?
Yeah, man.
I can make it even a little bit bigger.
There you go.
Okay, let's just move this over to the side. Okay, a couple of things I just want to do to it before I push it. This design, because it came from a design block, there's a chance that the 3D mappings have been lost. These were all made from the built-in Eagle library, so a quick update all will fix that. So go library, update all. Yep, I forgot to also polygonize, so bear with me 1 second. Convert to polygon, copy, bottom. Now name it ground, that way we pick up those signals. Okay.
That's a brand new feature on this version of Eagle that allows you to take enclosed shapes and polygonize them. Okay. And you can put them to any layer as well.
Yeah, just kind of taking advantage. Okay, cool. Rat's nest. Everything is connected. You'll notice that the rendering order changes depending on what layer has preference. So right now bottom has preference, so it goes on top of everybody else. If I switch to top, then it looks more like what we're used to. So if you're running into that, just double check your preferred layer. So now, let's go ahead and push this back to Fusion360. Push. Polygon included now.
This notation is actually, it can be read from Fusion360. We'll demonstrate that in a few minutes.
Let me save the design first, actually. Now we push. Polygon included. Okay, it's been pushed to Fusion360. Perfect. Both are up to date. That's what we want to see. Now we go back to Fusion. We close this. See, data has been updated. We can refresh.
So yeah, it doesn't, just to let you know, it doesn't automatically is going to load it in Fusion 360. Okay, so you got to refresh and then open up the project as well. And as you could see, each time he was pushing and pulling, a new version has been created.
Okay, so at this point, we have the board, we have our models in, and we have the option to start designing an enclosure. So one of the ways we can do that is we can start creating sketches to form the enclosure based off of the current shape, for example. That's one option. And that's the one that we'll start with today. Again, there are many ways to skin this cat. So if you have a preferred drawing workflow, if you have a different way, that's going to be perfectly valid. Fusion 360 likes to give the tools for you to work the way that you want to work and the way you prefer. So what I'm going to do is I'm going to go ahead and create a new projection, and I'm going to create a new sketch. So we're going to go ahead and go to construct an offset plane. Okay, and I want to make it on the back face of this. So I've selected it. I'm going to put it maybe 5 millimeters away from the bottom of the board. That way we have a little bit of space in the enclosure. So I'll type in the number 5. And you'll see we get that separation on the plane. Say OK. Now what we want to do is we want to project this outline onto this offset plane. So we'll go ahead and do that. I'm going to go Sketch, Project. So it asks us to pick the plane. OK. And now we're going to pick the outline that we want to sketch onto it. So I'm going to click here, just picking the outline. I'm going to zoom out so I can get the whole thing. And I'm going to get this little circle. So I'm going to say Enter, stop the sketch, and now if we look, there's that sketch. Okay, that's been projected on. Okay, so temporarily I'm going to turn off the board and the components just so we can have a better look at this sketch because we're going to be doing a few things with it. Okay, so what we want to do now is we want to go ahead and create an offset. What this is going to allow us to do is form a shell. Okay, so offset. Okay, so I'm going to pick this one, and you notice you can go beyond it, or you can flip it internally and make it go the other direction. So we can increase it in either direction. So I'm going to go with this one, 1 millimeter. So it's going to be a 1 millimeter thick shell. Okay, and I actually did it the wrong way. Let's go ahead and do it again. Offset, select the sketch curves, this one, okay. Want to flip the direction so that they're outside of the board. Again, 1 millimeter is fine. I'll say OK. So now I have this shell, and you'll see that it will actually detect it as kind of like a shell outline. I'm going to do the same thing with this hole, so that way we have a little bit of a lip around a cylinder. So we'll do the same thing here. I'll go Sketch, Offset again. I'll pick this object, this curve, and again 1 millimeter. Say OK, and there we go. So let me put it in a nicer view. And what we're going to do now is we're going to extrude these to get what we want. So before I actually do that, I'm going to create, no, we'll go with this. So we're going to go to Create, going to pick Extrude, and it's going to ask us to pick a profile. So I'm going to pick this profile, and we're going to give it a distance. So we know that this plane is about 5 millimeters away from the board. So we definitely want it to go past it, so that way it includes the board and closes it. I'm going to pick 15. But you'll notice it's going in the wrong direction, so you can just change the to a negative sign. Now it'll include the board inside of it. We'll say OK. Awesome. Now we can do the same thing again. Create the extrude. Let me make sure that the sketch is on so we can see it. To do an orbit operation, you just hold down Shift and middle click. And you have to hold down the middle click to get it to rotate. And it can be a little bit fishy sometimes. Okay, so this one, we're going to extrude that. Again, it's in the wrong direction. I'm going to take it 5 millimeters. -5. And we'll see that we have our little hole for where the bolt would go. Okay, we can turn on the board again just to get a view of where everything is lining up. And you can see there's a space for the hole, and that hole has a 1 millimeter lip to hold the board in. So now what we can do is we can continue again to play and adjust the enclosure. The last thing I want to do, because we are starting to encroach on that 30-minute time, is I'm going to go ahead and switch to the back here. And what I'm going to do is I'm going to project this outline in order to be able to make the back. Okay? And again, like I said, there's many ways to do this, probably better ways than the one I'm showing, but this one has worked for me. So again, we're going to construct, offset plane. I'm going to pick this surface here. Okay, I'm not going to extend it or anything. Just going to leave it right there. Put the sketch overlap. And now I'm going to click project. Which project? Here we go. Project. And now I'm going to specify what I want to project on there. So I'm going to pick this plane. And what I want to project is just the outside edge here. Just the outside. Okay. Perfect. So now what we're going to do is I can turn off the other sketches and it'll become clear which one we're dealing with, which is just this outside one. And again, what we'll do is we'll go create, extrude. We'll select those edges. Okay, and this time it is going to go in the right direction. Because the whole shell so far has been 1 millimeter, I'm going to keep that going here as well. So 1 millimeter. And there we go. You have the closed back. Okay. And again, I can turn on all the components back so we can see the full enclosure. Okay. Any questions so far?
No, not really. No. No, yes, no, not really.
Okay. Excellent. So obviously from here you can go ahead and do all sorts of things with the enclosure. You can add fillets, you can try to round it off, you can do chamfers, all sorts of things. So, you know, we can put a top on it, we can make other types of adjustments. Because if we look from the top, we have a little bit here. Now, one thing that makes Fusion extremely flexible is that you can change any of these objects regardless of where you are in the editing process. So for example, we have this extrusion, which I believe is the bigger one. I can go ahead and click Edit Feature, and I can change that size. Instead of 15, I can make it, 14, for example. And now everything else follows it. And you'll see that we have more gap here now. So it's very easy to go back and make adjustments. You're also going to be able to move components in the PCB, make other changes. So that's what we're going to do now that we've shown how you can make a basic enclosure. And we're going to make the change and push that back to Eagle. So again, I'm going to go to the home view, maybe even the front view. Let's go ahead and move something. So I'm going to go again, Edit PCB. Now we can pick Move PCB Components. Let's pick this one. Okay. I'm going to go ahead and move it over here. Okay. So we've relocated the component. Let's go ahead and say, we can also rotate it if we want. Okay, so let's go ahead and do that. Now you'll notice that the canvas doesn't automatically update. Okay, that can only be done in Eagle. So I'm going to say Finish PCB for now. And you can see everything else has stayed put. I'm going to save it. Say Moved Resistor. Say OK. And now when we go back to Eagle, Eagle's going to detect if something has changed. Okay, see, out of sync. We will pull from Fusion, move the resistor. I accept that. So as we can see here, the traces are pretty well messed up. But we can fix that. So you can rip it up. You can go ahead and try to move the trace. So we can do something like try to relocate it. Whoops, I had the route command active.
I would recommend rip it up, but that's me.
You know? So you could also do a route and go around, use a loop removal feature. Let's see if it'll catch it. Let's try that. Okay. Yeah, see? So you can do that. Now the width is obviously short, so I'll go ahead and change that. You can just type in width in the command line. So 10 mils is the right width. There we go. Perfect. And I'll fix this one because this is in a 45-degree angle, as you guys can see.
I think your grid is too coarse, Jorge.
Nah, I just had to turn it so that the automatic axis rotation would happen.
Okay.
And there we go. So now that's a nicer route. I will also put that to make it 45.
I was going to ask you to use quick route magic to optimize that one.
Yeah, we could also do that. Let's go ahead and see what quick route does. So quick route has a smooth signal function, which is really nice. It'll clean up any additional bends. And so if you just click on a trace, you'll see that it made it nice and straight. I can do the same thing here. Really, straightens it out, tries to minimize length. So now we can be happy with this. Save it. Push it back to Fusion. Cleaned up traces. Push.
Now, remember that when you push it to Fusion, it's not going to automatically load. It will just give you a refresh notification, in which then you could close the existing project. You'll see it as a different version, and now you'll load that one again.
Okay, so we go back to back to Fusion. Okay, we'll see that refresh option. I'll go ahead and close this. Refresh. You can tell if the version updates live PCB, version 5. Open it up. And there we are. Updated resistor. Everything looks as it should. So it's really good. You can see how easy it is to go back and forth between the two realms. If you have a mechanical engineer, you can make it even easier on yourself just by having them work in Fusion, just go back and forth together. And any notes on the versions you can always follow. If you click here on version 5, you'll see that it will expand, and it will tell you. You'll have the description of the changes. So move resistor, polygon included. I can show off 5 versions. I can go back to any of the versions. So it's always helpful to fill out the descriptions. Please do that. It's going to make it easier for you to know what changes were made. It's going to make it easier for the mechanical engineer, if it's not you, to see where maybe something went wrong.
I cannot express how important that is. It's extremely important that you actually take advantage of those notations. That way, every time you progress throughout the project, you could go back to a version if necessary, okay?
Okay, so that's everything for our demo today.